But the goal of today's lesson is to be able to solve real world problems using our quadratic functions. So things like area or projectile motion, you have to know what the problem is asking you to do. And then we've learned a bunch of different ways to solve quadratic functions over this unit. So the way that you choose is really up to you. So that's kind of the nice thing about it. And then also another nice thing about it is after all that Aspire prep, hoping you guys have a good understanding of like area by now. So I think this lesson will go by rather quickly. I am recording right now and I'll link it in the slides like I always do. If you want to watch the examples from last year, feel free. The practice you picked up, it'll be evens or odds. There's two sides to it, so just do the evens or odds on both sides. And that, whatever you don't finish today, will be homework. I want you to have it done by the time you walk in on Monday. So I feel like I don't actually give a lot of homework because it only ever becomes homework when you don't finish. So this is like one of the few times where it's like you'll probably have to do it at home. So just make sure you get it done. Because on Monday, when you walk in, we're going to go over the answers really quickly, do the exit ticket, and then play like a little review game for topic 8 afterward. So you know Mondays are short, so it probably won't be very much that we get done. And then Tuesday, I will not be here. I have to do curriculum writing, so I'm still going to be working. I just won't be here. You guys will have a sub, hopefully. Sometimes they make that sub go to the auditorium, and you guys know how I feel about the auditorium. Either way, what you guys are supposed to be doing on Tuesday is working on your topic 8 review packet, which you just picked up today. It's a green packet. I didn't mean to put on big paper, but kind of happy that it is so that we can easily find it. That's what you'll work on Tuesday. Unfortunately, I won't be here to go over it with you on Tuesday, but I will have the key taped to the back wall, but it'll only have answers, no workshop. I'll also post it in Schoology too. So even if you're in the auditorium, you can see what the answer should be. If you have specific questions about like, I don't know how you got that answer, I think I'm doing it right, whatever. You can email me and I will respond because I am again working, I just won't be here. You can go to tutoring and ask. You can, I don't know, reach out to me ahead of time, but I will have the key posted, just no answers, just no workshop. So if you have specific questions, you need to reach out because I won't be here Tuesday. Your test is on Wednesday for topic 8, your first attempt. And then your retake for it is Friday. So don't waste either opportunity because if you ever want to do additional retakes on something, because that's what they are, I always schedule the retake in class. Anything else would be additional retakes. Then you have to come to tutoring. And I'm only available Fridays, and there's not very many Fridays left. I listed them. So if you've been meaning to retake a test, make arrangements, find a ride. I don't know, but those are the days that I'm available for that. If you need to like prepare for the retake, you're welcome to go to tutoring in the library on Tuesday, Wednesday, and Thursday and get extra help from like real teachers. Like there's actual math teachers in there that can help you. The reviews are in Schoology, so just ask them to help you with the review and then come and retake it with me on Friday. So any questions about that? Anything? All right, then on to the notes. Let's start with the area problems. And for quadratic functions, we usually just look at area of rectangles. What's the formula for area of rectangles? Good. Base times height. I think in a lot of these examples, they say length and width. Same difference. I prefer using base times height, but length times width, same thing. So in example 1, it says, given the diagram below, find the value of x if the area of the rectangle is 78 square meters. So my area is 78 square meters, so that goes here. My length is what? X, you could say this is the length. What's the width? X plus 7. And we're multiplying them together because that's what the area formula tells you to do. Does that make sense, the setup? Once you do that, we'll multiply the length and the width together. So distribute that x. What's x times x? X squared. What's x times 7? And then bring down that 78 that was there already, the area. And we know it's a quadratic function because of that x squared. And really the method that we use to solve can be any of the ones that we've learned. Like if you have a graphing calculator, you can use that graphing calculator. I'm going to show you a different way because on your computer test, you don't really get to use decimals. There's still a graphing calculator in there, but I don't think you guys have practiced enough with it. So I'll just show you another method. How do you want to solve this? Do you want to use quadratic formula, completing the square, factoring? What do you guys want to do? Quadratic formula? Sure. In my last class, we did completing the square because it's already in that format, like the ax squared plus bx plus c. On the notes uploaded online, it's by factoring. So really, you can do whatever you want. But if we're doing it by quadratic formula, what form does this need to be in? And how can we make it standard form? Good. So this would be standard form. We need to move that 78. How do we move it? And whatever you do on one side of the equal sign. Good. There's no like terms on the right side. So I have x squared plus 7x minus 78. All right, if we're doing quadratic formula, I'm going to put it over here, the plugging in and stuff, because I'll need more space. But the formula is on the board for your reference. So plug in your A, B, and C. What's B in this one? So I have a negative B, a negative 7, plus or minus the square root of B squared, so 7 squared, minus 4 times A. What's A in this one? 1. And then times C. What's C in this one? Negative 78. All over 2 times A, which what is A in this one? 1. So then start simplifying it. This is just plugging it into the quadratic formula. Anyone confused where these numbers came from? All right, so then start simplifying it. I get negative 7 plus or minus. I'm going to put the discriminant in the calculator over 2 times 1. What's 2 times 1? 2. So put the discriminant in the calculator. That's all the stuff that's under the square root symbol. So I have 7 squared minus 4 times 1 times negative 78. Don't forget to use parentheses. And I get 361. All right, I don't know if that one's a perfect square, so let's see if it is. All right, look, it is. That's nice. So then I'm going to replace that part of the problem with 19. because the square root of 361 is 19. Any questions on how we got this? Okay, let me make it look nicer because that's like. All right, and then we need to solve for both cases. I'll put my answers over here. What's -7 plus 19? 12, and then what's 12 divided by 2? 6. And then what's -7 minus 19?
This is just a test. Thank you.
-26, and what's -26 divided by 2? -13. Now, is it possible for us to have,
Once again, that was just a test. Thank you very much.
all right, is it possible to have two values for x in the same shape? No. One of these does not make any sense. Which one? The -13 does not make sense in the context of this problem. Because can I measure something and get -13? No. So x is 6. And let me see what the question is specifically asking for. It just asks for what the value of x is. So x is 6 meters. Any questions about that? All right, sometimes it asks for not like just what x is, it might ask for like the dimensions. So like what the length and the width are. So in that case, I would say the width is 6 meters and the length is 6 plus 7, which is 13. So just make sure you look closely to what it's asking. Real quick, I'll just show you how in here, oops, hold on. I'll just show you how in here they did it a different way and got the same answer. They did it by factoring. But I think factoring for this one is a little hard because it's hard to think of numbers that multiply to 78. All right, any questions? Do you want to try one or do you want to see one more? Okay, let's look at 5 together and then I'll give you one to try. And this time we'll use a different method than quadratic formula. So number 5, it says the length of a rectangular garden is 4 meters more than its width. And the area of the rectangle is 60 meters. Find the dimensions of the rectangle. So it's 4 meters more than its width. Do we know what the width is? Does it say anywhere in here like the width is this? No. So what do we always label unknowns? As x or some other variable. Then it says that the length is 4 meters more than the width. So 4 compared to x. What does more than tell you to do in math? So then my length is going to be 4 plus x, because that would be 4 more than the width. Make sense? And then we're also told that the area is 60 meters. So then plug in both of these into the formula for area so that we can solve for x and then find the dimension. So it wants the length and the width. So in this one, we want the length and the width. All right, so plug it into your formula. We know that the area is 60 on this one, equal to length times width, or base times height. What's my length? X plus 4 or 4 plus x, same difference. I'll do x plus 4. So that way it will already be in standard form. And then times the width, which is x, multiplied together. So multiply them, distribute that x. What's x times x? And then what's 4 times x? Good, any questions? All right, so I said we won't solve this one by quadratic formula. Let's see another way. You want to do it by completing the square or by factoring? All right, let's do it by completing the square. It's already in that format, so the ax squared plus bx equals c. So yeah, we can easily do that. So if you remember those steps or have them on your notes somewhere, then you know that after making sure it's in ax squared plus bx equals c, that we take half of b, which was b in this one. We take half of it, then we square it, then add it to both sides. So what's half of 4? And what's 2 squared? 4. And then you take that 4 and you add it to both sides. What's 60 plus 4? 64. And then on the right side, I now have a perfect square trinomial. So we solve, well, we factor that. Set up your diamond, what number would go on the top? What number on the bottom? What 2 numbers multiply to the top and add to the bottom? Good, and if you remember, they should be the same number that fills in the diamond. So that we can write it as x plus 2 squared. And then solve for x. So how do you cancel a square? Take the square root, whatever you do on one side. What's the square root of 64? Good, don't forget the plus or minus. And the square cancels out. I just have x plus 2 on the right side and get the x by itself. What's opposite of adding 2? Good. So then on the left, I have -2 plus or minus 8. We'll solve for both cases. On the right, we just have x. So then my solutions will be -2 plus 8. What's that? And then -2 minus 8. What's that? One of these answers doesn't make sense though in the context of like a real world problem. Which one doesn't make sense? Good, because I can't have a negative measurement on this. So 6 is our x. But if you just put like x equals 6, that would be technically not full points because the problem asks for the length and the width. So if x is 6, then what's my length? 10. And we're talking about meters, so 10 meters, 10x. 4 plus 6 is 10. And then what's our width? 6 meters. Because the width was just 6. Questions? All right, then you try number 6, and again, you can use whatever method you want. You could factor, you could do quadratic formula, you could complete the square, but 6 will be your turn. So I'll give you like 2 minutes. So number 6, if you got it right, you would have had that the dimensions are 9 and 3. So for this one, I think it's helpful to draw a picture. Says that the rectangle has a length that is 6 meters less than its width. Does the rest of it, does it tell you what the width is? No, so how do we label unknowns? As the x, and I'm putting it on the shorter side. It probably should rather be over here, but whatever. One of the sides is unknown. The other side is 6 meters less than its width. So what does less than tell you to do in math? Subtract. And should it be 6 minus x or x minus 6? X minus 6. So if you put 6 minus x, change that. Remember that anytime it says like less than or stuff like that, that's a switch word. You switch the order. If it's less than, it should be x minus 6. So then it also says that the area is 27 square meters. So that's what they set up right here. Area equals length times width, or width times length is how I wrote it. And then you multiply them together. So what's x times x? X squared. What's x times negative 6? Good. That's how we get it to look more like a quadratic formula. And then since they chose to solve it by factoring, which honestly probably would have been the easiest in this one, they needed to have it in standard form. So they subtracted the 27 on each side. And it's now in standard form. Set up your diamond. What number would go on the top? Negative 27, what number on the bottom? What two numbers multiply to the top but add to the bottom? 3 and negative 9 is the correct combination. So that way it adds to a negative. Then you set each one equal to 0. So each factor, x minus 9 and x plus 3 equal to 0, and solve for x. And that's how we get x equals 9 and negative 3. Except for that, we don't use one of those. Which one do we not use? The negative 3. Because you can't have a negative length or width. So now we know x is 9. So one of the dimensions is the 9 meters. The other one would be x minus 6. So 9 minus 6, which is 3. So that's how they get the answer. Questions? All right, so I think that's enough area for today. Let's look at the back side, which is projectile motion. Now, the unique things about quadratic functions is that they make like that U-shaped graph, the parabola. Those graphs can be used to represent like throwing a baseball, throwing a basketball, things like that, dropping something from a building. So really we're only going to be looking at the negative parabolas, the one that opened downward. And for these problems, at least on the resources that I have, they usually will give you the equation that you need. Like here, like they'll say this equation represents a soccer ball being kicked from the ground with an initial upward velocity of 90 feet per second. So most problems will give you the equation. However, I have seen some problems on the Galileo tests that ask you for the equation. They make you make it yourself. And on your exit ticket, it'll ask you to make the equation. So on the board, I wrote the equation. I decided I'll give it to you. You can also write it on your notes. That the standard equation for projectile motion is h of t equals negative 16t squared plus bt plus s, where b is your velocity and s is your starting height. All right, and then H, I'm not gonna label those because I feel like those ones you can remember. H would be for height, and T would be for time. So then if it asks you to make the equation, use that setup. So like it says the velocity is 90 feet per second. So that's why the 90 replaces the V right here and goes in front of the T. And this one doesn't say anything about like the starting height. So for this one, the starting height is 0. Questions? All right, I'm sure there's some sort of scientific reason why it starts with a -16 always. I just don't know it. I'm sure it has something to do with like gravity or something like that. But that's how the equation is for projectile motion. All right, and when it says find the maximum height, where would the maximum height be on your parabola? Would it be like down here? In the middle at the highest point. What do we usually call that in math? What do we call it like in the beginning of this unit? The middle of your parabola, what's that called? Your vertex, all right? Start looking over your notes. Your test is on Wednesday. All right, yes, the middle of your graph is your vertex. So if I can find the vertex, which is normally in the form xy, then I can find my maximum height of the ball. They don't use x and y's in this given formula though. What letter is in the place that the x normally is? What letter? The T is in the spot where the X normally is. And then the H is in the spot where the Y normally is. So just label it like that. Your vertex is TH, where T is time and height is where H is height. So we're trying to find the H of our vertex. Now you can do it by hand. I think I'll show you with the graphing calculator first. So that's like the easiest. Hold on until I have it. So to use the graphing calculator, I'm going to type in the equation. It does not read T's. So you're going to have to put the X in the spot where the T is. And then if we're looking for the maximum height, that would be way up here. And again, it goes in the order T, H. So is it the 2.8 or is it the 126.6? That's our maximum height. Good, it's the second one. So our vertex is 2.8 about, comma 126.6. So our height, I'll squeeze it in here even though I don't really have room, is about 126.6 feet. Questions about that process? All right. Then part B says how many seconds, so we're talking about time, will it take for the ball to reach the ground? Would that be the 2.8? When the ball reaches the ground? No, the 2.8 is when the ball reaches the maximum height. If I want to know for when the ball reaches the ground, I'm going to have to go to like the x-axis, because that's kind of like our ground. And it intersects at two spots at the x-axis. Well, one of them is when like I haven't thrown the ball yet, and the other one is when it's reached the ground. So which one is when it's reached the ground? the 5.625. I'll round it, it doesn't specify what to round to, but about 5.6 seconds. So when it's reaching the ground, that's when the height is 0. There's two parts where the height is 0. Pick the one that makes the most sense. Questions? All right. I want you guys to try this next one. So you guys try number 2. And then I'll show you how to do number 3 without a graphing calculator, just because you won't always have a graphing calculator with you. All right, so try number 2. I'll give you like 2 minutes. All right, so if you got number 2 right, you should have had 144 feet for the maximum height and 5 seconds for the ball to reach the ground. And in Desmos is probably how you did it, because I haven't shown you any other way yet. But just remember, like, for the maximum height, we're looking for the vertex. And they arrange it in the order t comma height. So for maximum height, we're looking for the y of our vertex, which you can easily do with a graphing calculator. But you don't always have a graphing calculator. I mean, even when you take the Galileo test, there is a graphing calculator in there, but a lot of students don't know how to use it. So here's how you can do it by hand. Remember that we used to find the vertex by hand. With that, you needed your axis of symmetry formula, x equals negative b over 2a. What is b in this equation? 64, so that's where they get this negative 64 from, because negative b over 2a. What's a in this situation? Good. And then when you do the math for that, you get negative 64 over negative 32, which is equal to 2. So that is my x of my vertex. How do you normally find the y by hand? You plug in your x. So then they would do negative 16 times 2 squared plus 64 times 2 plus 80. And then you would put this whole thing in the calculator exactly how it looks. And you know what you get when you do that? 144. So that's another way to find it if you don't have a graphing calculator. Questions on that process? All right. And then when we're talking about how many seconds will it take for the apple to reach the ground? Well, at the ground level, what's the height value?
8.
When it's on the ground?
0.
0. So 80 is actually your starting height. And h is 0 is when your ball has reached the ground. But technically, like when you type it into Desmos, it'll give you 2 answers. You need to pick the one that makes the most sense. So they chose to make the h 0 or make the y 0, and they chose to solve it by factoring. So GCF is negative 16. Then they factor the parentheses, negative 5 on top, negative 4 on the bottom. What 2 numbers multiply to negative 5 but add to negative 4? Negative 5 and 1. There's not a lot of options for things that multiply to 5. So try 2 and 3, try 5 and 1, see which one needs to be negative to make it work. But that's what they get here. And then they set each factor equal to 0 and solve for x, or t in this case. And out of these 3 answers, the only one that makes sense is the positive answer. Can't have a negative time. So that's why they get T is 5 seconds on this one by hand. But again, feel free to use decimals if you have access to decimals. Questions? All right, just one more, which is the third one. You guys try it now with the doing it by hand. Feel free to verify with Desmos, but just try it once by hand and see if you can do it, because you don't always have access to a graphing calculator. So if you did it correctly, you would have had that the maximum height is 25 feet, and the time that it takes to reach the ground is 1.25 seconds. All right, and then look at the scratch work, make sure you have the scratch work, even if you use Desmos. It's nice to have it. So it gives you the equation. If you ever have to make the equation, just look up at the board. Velocity goes in front of the T, and the starting height goes at the end. It's your constant. So in this one, there's no velocity because they're just dropping something. They're not like throwing it or putting like force behind it. So in this case, if you solved it by hand, you need your axis of symmetry formula. Why is B 0? Because there's no T term. There's a T squared and there's a constant. That's our A and our C, but there's no B. So it's 0 over 2 times A. A is negative 16. What's 0 divided by any number? 0. And then to find H, you plug in your T. Negative 16 times 0 squared is what? And then plus 25 is, that's how we get that. Good? And then how many seconds will it take for the container to reach the ground? At the ground, what is the height? 0. So plug in 0 for the H. In this one, it looks like they solved by completing the square, kind of. They rewrote it to x squared plus bx equals c, which there is no bx. It's just 16 t squared equals 25. Divided 16 on each side. Took the square root on each side. When you take the square root of a fraction, take the square root of the top and bottom. You get plus or minus 5/4, which 5 divided by 4 is 1.25. Again, if you have access to Desmos, use that. But if you struggle with the graphing calculator on Galileo, you can do it this way. All right? So do your practice over the weekend. Have it done by the time you walk in class on Monday so that you're ready for the exit.